I want to go ahead and take this opportunity to wrap up the review of the chapter 1 test that we started last week. I think we kind of left off on this problem. There's just a few to go. So let's go through those today. I think I've got some additional resources up there. I'll make sure that there's plenty of stuff up there for you to be, looking at if you want to. I've got the review assignment for the test is really key. I know in some cases people hadn't finished the review before they took the test, and that's probably why they didn't do well. I'll give you an opportunity. Let's go ahead and say Wednesday. That sound good? Wednesday we'll do our retake in the lab. Tomorrow I'll probably just do something, a chapter 3 thing, an introductory thing for chapter 3, and then we'll test Wednesday and we'll keep moving. Okay, sound good? All right. So let's take a look at this one now. These are the ones that are. This is a little harder. I mean, this is one where we got to set up and solve an equation that's quadratic. So that's not an easy thing to do, but we're going to do them all year. So we got to just get to a point where we're comfortable with these. They're all going to follow kind of the same pattern. So how do we set this up? If we know that point S is between points R and T, what does that picture look like again? Remember? What am I going to draw? Segment
R, T.
Okay, good. So it's going to be, I'm going to get something like this, aren't I? There's point R, there's point T, and point S is just somewhere in between, right? Okay, so here's the part, though, where the geometry is pretty simple, right? We want to be able to set up some kind of an equation, though, that's going to allow us to solve for the value of X so we can plug back in and get the actual lengths of these segments, right? That's the goal of this problem. So what's the geometry relationship? What do we know here about these 3 lengths? What do we know? What do they mean by RS again? What is that? Okay, the distance between R and S, same thing as the length of the segment. So let's maybe color code this a little bit. So we'll make this one red, how about? There it is, right there, right? No big deal. What about ST? Well, that's the length of this segment, right? And then RT would just be that distance, wouldn't it? It's the length of the whole thing, right? See that did there? Red and blue makes purple. That's okay. So what does that mean in terms then of an algebra equation? What do we get? Okay, good. So we're just going to get the length of the whole thing, RT, is just equal to that short length plus that short length. And look, we've got expressions for all 3 of those, don't we? Right? So this one just becomes 4x squared plus 4x minus 423 equals 2x squared minus 232 plus ST is x squared minus x minus 125. Okay, question so far, does that make sense? All right, so that might look kind of scary, but don't let it be. It's not that big a deal. What do we do with it? Now we're just in algebra mode, right? We can forget the geometry for a while. What do we do first? Combine like terms. Very good. Okay, so on the left, everything's pretty much already taken care of, right? I've just got my 4x squared plus 4x minus 423. There are no like terms to combine there. But on the right side, we do have some. What about x squares? How many total x squareds am I going to get? 3x squared. Good, 3x squared. And to get there, we combine those two, right? Okay, how many x's?
Only one.
Yeah, just one right there. Minus x, so that one's taken care of. And then we've got some numbers to combine, negative 232 and negative 125, we
So
said
it'd be
was
negative
357.
357, good, okay. And did we get them all? Looks like we did, right? So now what?
You put up the other side.
Okay, good, so now here's where things maybe get a little bit different than the easy problems that aren't quadratic, right? Remember, if we have a quadratic equation, we've got to put it into what we call standard form, which means we're going to get everything on one side, and the other side's going to be equal to 0, right? There is an important step here, though. We want to make sure that we have a positive number of x squareds. That's really important, right? So which side are we going to move things to?
The left.
The left side, all right? So we'll then subtract 3x squared from both sides. How do we get rid of this x?
You just add six.
So we add x to both sides, and then here. Good. We gotta treat both sides equally. And so, what do we get? Well, those guys all cancel, right? And so, on this side, we get 0. How about over here? 4x squared minus 3x squared, just 1x squared. 4x plus x, good, 5x. And this is going to be a weird one, negative 423 plus 357. And let me say that's going to be negative 66. So that's our equation, right? We got it simplified. Now this is, it still may not look super easy, but it's the easy kind because we've got a 1 in front of the x squared, right? At this point, all of the quadratics I give you, you're going to be able to solve by factoring. Later on, we'll look at some other ways, but we can always solve by factoring for now. So what's the template that I set up here? What is the answer on the, what's the next step on the left side going to look like before we even write anything in there? Say it again. No, I can't do that. Remember, I can't do that. I can't isolate x here because my rule was always from before. My rule is always I can isolate a variable if I can point to a single variable, which I can't do here. I've got x squareds and x's, so I can't isolate x. I've got to do something a little different. Ruby? Okay, good. So I'm gonna, and what we're really talking about there is we're gonna try to be able to split this apart into a product of factors, right? So we're gonna factor the left side. That's good, because if we can break this apart into two small factors, then we can solve both of those equations that we get very easily, right? So we know that if this thing factors, it has to sort of unfoil into something like that, doesn't it? Right? What do the numbers have to do? So I've got two numbers that multiply to negative 66, right? Multiply to negative 66 and add to 5. So let's find those. So multiply to negative 66, add to 5. What are those numbers going to be? Yeah, we did this. So you might remember this. I just want to make sure we never finished it up. Right. So the numbers are positive 11, negative 6, right? Those numbers add to positive 5 and they multiply to negative 66, right? So plus 11 minus 6. Okay, and we're almost there, right? We're almost there. The last step then is we've got to say, okay, so we know the product of these two factors has to equal 0. This is where we use that 0 product property. What's the only way I can multiply numbers together and get an answer of 0? I have to multiply by 0. That's the only way to do it, right? No other two numbers will ever multiply to 0, will they? Right? So I know that the only way for this to work is if either this is 0 or that is 0, right? So first of all, what's the value of x that's going to make that first factor equal to 0? What plus 11 equals 0? Negative 11, right? And if I want to, I could set that equal to 0 and solve, but it's pretty easy. I don't think I really need to. So either x equals negative 11 Or what's gonna be the value of x that makes that factor 0? Yeah, 6 minus 6 would equal 0, right? So those are our two possibilities. Either x equals negative 11 or x equals 6. And we'd have to just go back and try them and see which one works, right? So let's do that. I think I can be tricky here. What if I go? Oh yeah, that's good. Right. So let's try these things then. So what if we try out, what if I try 6? Is 6 gonna work? If I plug 6 in, we're gonna get problems, aren't we? If I plug 6 in, I'm gonna get, for example, here, I'm gonna get 2.
Minus 232, which makes that be.
Yeah, I get a problem, don't I? I don't even have to do it. I can just see that it's gonna be negative, isn't it? 6 squared is 36. Wouldn't you agree 2 times 36 is gonna be some positive number smaller than 232? So I know this is gonna give me a negative number, right? And so 6 is not gonna work. That's not the value of x that we're gonna use. So instead, I've gotta go back and use, whoops, not that. Gotta go back and use negative 11, right? And you can use a calculator for this, right? So now, what's this gonna give me? RS is gonna be 2 times negative 11 squared minus 232. We could just plug that in the calculator. What should we do though? We talked about this many times. When I square a negative, what should I always do? Either put it in parentheses or even easier, just square the positive, right? So that's the same thing as saying 2 times 11 squared. 11 squared is 121. 2 times that would be 242. So what is 242 minus 232? 10. Okay, so RS is 10. What about the next one? If I plug in negative 11. Negative 11 squared minus negative 11 minus 125. Well, negative 11 squared, same as positive 11 squared. 121, subtracting a negative is what?
Plus, will be add,
Good. Add it.
121 minus 125, which is
So what is that?
6.
7?
6.
Okay. That's gonna give me 7. When all the dust settles, if I add those up, I get
Oh, yeah.
132 minus 125 equals 7. So if I've done this correctly, do I even have to plug in for RT? What's it gonna be? 17, right. And we could plug it in and verify that. But that's the answer. Okay? That would be a good way to check my work though, wouldn't it? If I plug in negative 11 using a calculator here, I better get back the answer 17 or something's wrong, right? Okay. Moving on. So this is where we didn't get to this one, right? This is another one. I think this is a little bit easier personally, but you can be the judge. So they want us to find the values of x and y and then find the measure of angle PBS. So this one over here, right? We could maybe be easier if we wrote in the values of each of these angles, the measures of each of these angles in terms of x's and y's. So APB or ABP would be this one right here. We're told this one has a measure of 5x plus 4y minus 91. PBS is 2x plus 6y minus 141, and then SVJ is 3x plus 4y minus 59. So how many different kinds of variables do I have? 2. Unfortunately, there's no way for me to set up relationships with just one variable. All those expressions involve both x's and y's. So how many equations am I going to have to solve for 2 unknowns?
2.
I need 2. So I've got to use 2 geometry relationships. So what's one of the geometry relationships that I can use if I have 2 lines that cross? What do I know about these angles? What do I know? What do you think? Ideas. Mallory, you have an idea? You tell me anything about those angles up there. Say it again. Vertical angles? Okay, so those two, what about them? They're the same. They're congruent, so their measures are equal, aren't they? So I could set those two measures equal to each other, and that's gonna give me an equation, right? So let's do that. So we get 5x plus 4y minus 91 equals 3x plus 4y minus 59, okay? That's good. That's an equation, but remember what I've got to do, my goal here is I've got to write this as a linear equation in standard form, in the form, this goes back to that algebra review. We want to get something in the form a number times x plus a number times y equals a number. So what that really means is I'm just going to get the x and y terms on the left and the numbers on the right. Okay, and then that's going to give us one equation like that. We're going to get another one from maybe a different relationship, and then we'll just solve the system in the easiest way, either by substitution or by linear combination or elimination, whatever you want to call it. So what do I do here to get the x's and y's on the left side? What am I going to do? What do you think? Some ideas. Vanessa, an idea. If I want to get the x's and y's over there, what do I have to do to this equation?
Subtract the 4.
Say it again. You're on the right track. Say it again.
Subtract the 4 to
Okay, so I want to subtract stuff from over here to over there. So there's an x term. How do I get rid of that 3x?
subtract.
So specifically, we'll subtract 3x. That's good. I got to get the y over there. So I'm going to subtract that also, right? Okay, that's good. That's going to get rid of those. And then on this side, I'm going to get 5x minus 3x. What's that? 2x, 4y minus 4y goes away. That's good, right? And then I want to get the numbers on the other side. So what do I do with this one? Yeah. Because I want the numbers over here. So 59, negative 59 plus 91 is what?
No.
30, was that 32? Is that right? I think so. So there's one equation, 2x equals 32. Okay. Okay. We need another equation though. So we use the fact that those two are congruent. What's another one? What's another one? Maddie, what's another relationship between those angles? I know these two are congruent, so their measures are equal. What else? Okay, so say those two. What can we say about those two? They're supplementary. Yeah, so their measures must add up to what? 180. And we know that because they're a linear pair. There you go. Okay, so there's our other equation. Very good. So the other equation then tells us, I'm going to put a box around that one because that's good. We got that one to use. Now we got to build another one. So this plus this equals 180, right? 2x plus 6y minus 141 plus 5x plus 4y minus 91 equals 180. Same drill. We're just going to get the x's and the y's on one side and the numbers on the other. Well, the x's and the y's are already on the left. I can just combine like terms, right? Okay, so what am I going to get, Carrie? What am I going to get if I multiply or if I add up my x's on the left side? 7x, good. So those combine to 7x. What about the y's? 10y. Very good. And while we're at it, let's go ahead and add up the other numbers. We're going to end up subtracting to the other side. But what is negative 141 plus negative 91? What is that? Negative 232, I think. You can check me. I think that's right. So then we really only have one more thing to do. What's that? Yeah, add 232. I want to get the numbers over there, right? So we'll add 232. So those cancel. and I just end up with 7x plus 10y equals, that's big number, what is that?
To be.
4,
It would be
412?
412. 412. Yeah.
Okay. All right, so we got these two equations then, right? There's equation 1, there's equation 2. Now we kind of lucked out. We're going to be able to just use substitution here. It's going to be pretty simple. It would have been a little harder if we'd had maybe a y term there, right? But we didn't. That's good. So I'm gonna write that system down again, so we can look at them at the same place. 2x equals 32, and 7x plus 10y equals 412. What do you think? Suggestions? How am I going to solve this? What do you think, Ruby? Yeah. If I divide both sides by 2 here, what am I going to get?
16.
X equals 16, that's good, right? All I have to do then is
Plug it in.
Plug it in and solve for y. So if x is 16, plug that in. 7 times 16
Would be like.
plus 10y equals 412. So what is that?
112.
112.
112.
Yeah. So I can subtract 112 from both sides. It's getting kind of far down there. That's convenient though. What's 412 minus 112? 300.
300.
So 10y equals 300. Divide both sides by 10. What's our trick? If I divide a number by 10, what am I really just doing? Yeah, just taking off a 0, right? So I can just do that. And I get 1 times y equals 30. So x equals 16, y equals 30. What do I have to do to get my answer? Plug them in. Just go right up here and, well, there's 2 of my answers. What did we say x was? 16?
Yeah.
Y equals 30. I just plug those values into there to get that answer, right? No big deal. Okay, questions? Okay, and then I think that's it. Yep, that was it.
Okay.
All right, so what are we doing?
We got 1022.
1022. Okay, so why don't? How about if we